How's it going, everybody, and welcome back to our Cisco Enterprise series. In this video, we are post OSPF multi-area implementation. So what we're going to be doing in this video is taking a look at some advanced capabilities. So we're going to look at doing a default route propagation inside of our OSPF implementation to see exactly what that looks like. So I'm going to be doing this on R33 so we can see what that would look like and see how that's going to correlate everywhere else in the environment. So without any further ado, let's go ahead and take a look at this configuration. So what we're going to do is on R33 is we are going to show IP interface brief and then do a show IP route. Right now we are learning a BGP route on R33 to R26. That is, so we have we're getting a BGP default route from there. Now on this device we have a lot of additional routes. So let me go ahead and bring down 33, bring this up so I can scoot this up. So we have a handful of BGP routes, right? And I've covered BGP already up to this point in the series, in the recording process, but we haven't gotten to BGP yet in the flow of the playlist. So if you see stuff popping up, that's why, and I made mention of this in the very beginning of the series, so I'm going to do my best to try to reiterate that you'll see things kind of out of order, and I did that on purpose. So we have a default route from BGP. So if I was to look at 34 though, show IP route, we have a static default route here. So I'm going to show you guys how to do both when it comes to doing redistribution or a default route propagation. We're going to look at how you can do it both ways. We're going to take a look at, we have a static route pointing out to the internet, which is a very standard deployment, but then we also have a BGP peering on one of our routers that gives us the ability of doing a BGP to OSPF redistribution. So we'll take a look at both. So the easy one is going to be on R34 because he's got the static route. So what I would do is if I look at, say, switch, let's look at switch 7, and I look at this, I do a show IP route. As you can see right now, I have my OSPF routes, everything looks pretty good, but my gateway of last resort is not set. So I don't have a default gateway. I don't have a default route. So unless I have a longer match route somewhere in my routing table, I won't know how to get to anywhere. So what I'm going to do instead is I'm going to go to R34 and I'm going to go to global config and I'm going to type in router OSPF 1, and then I have a couple of options underneath here. So let's take a look at exactly how this is going to work. So normally what I would do is I would do a default information originate. So, well, the reason why I would do that is if you look right here, it says redistribute. Redistribute information from another routing protocol. Okay. So if I was to type in, say, redistribute and say static, which I can do, and say subnets, which is considered subnets for redistribution into OSPF, that simply just means that we're going to include the classful mask. So if there is a, if you've got like a 10/22 or a 172/21, something like that, you're going to take into consideration the mask as well. So if I type this in and I hit the enter key, if we then go to do show IP OSPF database, and I come down here to my external routes, right, I don't have any type 5 LSAs, right? So I can hit the up arrow a couple times. I have my summary autonomous system boundary LSA, right, from 57. But if I look at switch 7 and I hit the up arrow, notice how I still don't have a default route, right? If I do a show IP OSPF database and I go to the bottom, I don't have a type 5 LSA. So what I need to do on 34 is not type in redistribute static subnets. what I need to do here is I need to type in default dash information originate. And I'll talk a little bit more about what these are here, since this is right here. What I can do, this always command is basically says always advertise a default route. I am not a proponent of that unless you have a very specific use case for it, but this is it's always on. Whether R34 has a default route configured or not, is learning it via static route or dynamically, it doesn't matter. It's always going to advertise a default route no matter what happens. You can specify the metric. So do you want to give it a higher metric than another default route if you have potentially a couple of them? Do you want to set the metric type to E1 versus E2, things like that? And then you can reference a route map variable to it if you would like to do so. So I'm going to simply hit the enter key here, and I'm going to go do show IP OSPF database, and we're going to go to the bottom here, and you notice how once I did that, the type 5 LSA is generated. Okay, with the tag of 1 being the OSPF process ID. Now if I go to switch 7 and I hit the up arrow, I go down to the bottom. Now I have a type 5 LSA, and the advertising router is 34. Notice that? The link ID is all zeros, indicating that it's a default route. If I hit the up arrow a couple times and I do a show IP route, now I have a default route. It's an external type 2 route, which is the default one you're going to get. And the next hop is going to be 10.7.41.41, which is going to be iOS XR 41. So that's essentially how that would come into play. So there's that. Now I can go in here and manipulate this if I wanted to and say I want to go on 34 and I want to manipulate it and I want to set the metric type to be a different value, stuff like that. So there are options for you to choose if you want to do that. Now let's go to 33, because now we have, in this particular case here, we have BGP routing, right? But if I go to router OSPF 1, I type in redistribute BGP, and the BGP AS number here, I believe, is going to be do show run section BGP 65001. Yep, so redistribute BGP 65001. And then I would use the subnets command to do this. Now here's the caveat. The caveat is this. I have just the default route here, right here, but then I have also these other longer, external BGP routes, right? 221.61, 222.29. These are BGP routes that I do not want to redistribute from BGP into OSPF and to propagate into my local network. And the reason why you don't want to do that is very, very simple. Let's say, for example, in the very small use case that you have a full BGP table in your routing environment. Right? On your edge, you have a peering to some provider and you're getting a full BGP table. So what's the average table now? I think we're like somewhere in the 800,000 routes or so. Now granted, we only have one BGP peering, so we're only going to get one copy of that full table. The problem with that, though, is if I just do a blind redistribute command like this, well, I say blind, meaning that I'm just going to blind trust. I'm just going to take whatever BGP is advertising to me. So let's say, for the sake of argument, let's assume that BGP is advertising to us 20,000 routes. Well, if I was to redistribute BGP just like this, and I'm going to demo it so you guys can see what this looks like, hit the enter key, and I go to switch 7 and I hit the up arrow, we are eventually going to start seeing, once the route propagation takes effect, and let's go back over to 33 and do show IP OSPF database. I come down here to type 5 LSAs. Notice how I have a bunch of other default routes as well, so on and so forth. If I go back to switch 7, I hit the up arrow, you're going to start seeing a bunch of other routes coming through as well, right? See the 126, 130, the 134, 42, etc. These are all routes that we're also going to receive. So this is not what you want to do. When it comes to redistributing another protocol, especially BGP, I'll say 95% of the environment of the time when you're going to see BGP used on the edge for a customer, they're only going to be getting a default route. There are going to be a small percentage of inside that 95 that are going to be getting the local carrier's routes. So you might get AT&T might give you 2,000 routes. Spectrum might give you 2,000 routes. You know, stuff like that. All you care about is the default. So how do you fix that? Well, here's the answer to that thing. So we really haven't dove into how redistribution works yet, but I'll give you a small inclination of how this works. When we're doing this config, you want to be specific with a filter mapping, and a filter setting. What does that mean? We're going to use a prefix list. The prefix list is going to match on the prefix and the length. This is not an access list, which access lists dig into things more in depth. So we'll talk about access lists later on. But a prefix list is going to be a subnet filter, or an access list can do subnet filtering, right? It can match on a subnet itself, the length and the map, and the prefix and the length. But more specifically, you can get into TCP, UDP flows, layer 4 information, TCP flags, things like that. You can get into all kinds of other stuff that we don't really need to worry about right now. So what I'm going to go do is I am going to go back to 33, and I'm going to jump out of global config, and I'm going to fix this so that we only get a default route. So the way we do this is we come in here, type an IP prefix list, and the name for this prefix list is going to be, I'm going to say BGP default. And I'm going to say permit, and I'm going to type in 0.0.0.0/0. This command right here is telling me I only want to receive a default route. Now there is the option of doing minimum prefix length and maximum prefix length, where this syntax right here is saying that I only want to receive a default route. Now if I typed in LE32, I'm basically saying I'm going to receive everything, from default route all the way up to your longest /32 mask. I don't want to receive that. All I want to do is receive that. Now it's going to squawk at me if I hit the enter key again, because it's like, wait a minute, you've already got that sequence number configured. Perfect. So what I'm going to do now that I have the prefix list configured, so I'm going to type in route-map. This is going to be BGP default. And there's, by default, the operation is going to be a permit, and the sequence number is going to be 10. So for the sake of argument, I'm going to say permit 10. So I want to allow this operation to happen. I'm going to say match on IP address in a prefix list BGP default. Okay, I want to match on that and nothing else. So I'm going to exit out, do show run pipe section BGP, or sorry, OSPF, and I'm going to go to here. But at the end of this syntax, I'm going to type in route map, and the name of the route map is going to be BGP default. Okay, if I hit the enter key, and I give that a couple seconds for it to do its thing, and I type in do show IP OSPF database, eventually this stuff should start to filter itself out. And there it goes. Now, what's interesting about this whole situation is it filtered it out, right? But you notice that the advertising router is still 10.0.0.34. Why is that? Well, the reason why that is because we are matching on BGP routes, and the default route, ironically enough, is a default route coming in through BGP. However, because it's the default route, it's not a longer match. It's kind of a quirk with the way that this works. So if we go back to switch 7, or we hit the up arrow one more time, go down here, and if I go type in do show IP route, right, we're going to take the BGP path, right, that's getting where it's got to go. And the reason, so we actually do have an alternative path. We do have a backup path to R34. So it's kind of a conundrum the way this is going to go. So if I was to go to switch 7, for example, and we hit the up arrow and hit the show IP route again, notice how all of those BGP routes go away. Now if I do a trace route to Google, numerically, actually trace route Google, and which path am I going to take? I'm going to go out towards router 34. I'm taking this path, right? 57 to 13 to 34. Now the reason why that's happening is because the only router that's actually doing any default route propagation is the R34. Even though we did a redistribution, it's kind of a weird quirk on how this works. But until you go and implement the default information originate, you don't get a default route to propagate. So what I'm going to go back to 33 and do is I'm going to type in, I'm going to take all this out, I'm going to type in no, do show run section OSPF again, and then we have to take this command out again. So we're going to take the route map, this out, we're going to have to do this again, do show run section OSPF, and then we're going to type in the command default dash information originate. Okay, now if I do show IP OSPF database, come down to the bottom, notice how now with the default information originate command I have two default routes, one from 33, one from 34. I go to 7, I hit the up arrow to my database. I have, again, the same thing shows up. I have a type 5 LSA, do a show IP route. Notice my default route doesn't change though. Okay, so it's still, I'm still going to take the path, trace route to quad 8. Now I'm going via router 33. Right? So why am I taking router 33? Why am I going 57 to 13 and then 13 looks at it and points me towards router 33? Why am I going that path versus router 34? Well, let's take a look. Well, before I show you, let me tell you what's happening. What's happening is the BGP default route is getting redistributed, and that's what's taking precedence. So if we do a show IP route, and we look at this, what's actually happening, so it's actually generating both. But it just from a load balancing perspective, it happens to take it's got both of them injected here. Now, this normally isn't that big of a deal, right? The job will get done. Here's the problem with that though. The problem is, imagine I didn't have routers. Because routers are stateless devices, right? They do not pay attention, nor do they care of what configuration or what data flows are going through them. You know, they're stateless. They don't pay attention to any of that. But now let's pretend like we had firewalls that are stateful, that actually do pay attention to what the traffic flows look like. This would not work. The reason why it wouldn't work is you can't send one packet this way and then the next packet this way. Now if we go back to switch 7 and I try to do that trace route again, I still go out 33, but if I was to do a show IP interface brief and then change my loopback to loopback 7, trace route again, quad 8, source address is going to be 10.0.0.7, yes. From a forwarding perspective, it looks like the Ceph process on 13 is like polarizing me. If I do a show IP Ceph and I do a 0.0.0.0 internal, it is 0/0. So it's going to attempt to send me out 33 first, because that's the first of the two hashes when it hashes the traffic. That's the first of the two. So if I had multiple flows going out at the same time, let's see if I try to do this from switch 8. Trace route. That one's going via 33 as well. Okay, so for whatever reason, I'm not able to trigger it to go via 34. I probably could manipulate that if I was to change how the Ceph algorithm is taking a look at this, but we're polarizing. Now, typically speaking, this is not what I would want to do. if you were my customer, and I'm going to put on consultant hat just for a moment. So, okay, you've got two different internet egrresses, right? You got one going via a BGP learn default route, the other one's a static default route going onto a cable internet or fiber internet, whatever it might be. Both are valid designs. Both are going to work the way we expect them to. Both are the same speed, right? We both have, say, 1 gig internet circuits. Here's what I would do. I would say, okay, we have to pick one or the other, because on the edge, we don't have the luxury of sending traffic to both. We have to pick one or the other. So we'll pretend for the sake of argument that router 33 and 34 are firewalls. So they are statefully inspecting the traffic as it leaves the network and goes out to the internet. What do we do then, Rob? Well, what we would do is, which internet circuit do you want to be used as primary? I want 33. Perfect. If we look at switch 7, and we look at the show IP OSPF database, I don't know how far back I want to go. I might have to type in the command again. If you notice right here, and we look at the external, we can see that both of them are type 2, right? They're both type 2 external type 2 LSAs. So what we would need to do is pick a direction to go with. And what I would suggest you do is on 33, when we do the default information originate command, we would specify the metric dash type to be 1. Now, E1 is preferred over E2. E2 is the default, but if you choose E1, E1 will be preferred. So that's what we would end up doing. So what I would end up doing is going on to R33, and I would type this command in right here. Then I type in do show IP OSPF database again. Come down here. There's really nothing changes, but if I type in external and look at it, we're going to see metric type 1, and then we're going to see metric type 2. Now if I go over to switch 13 and I hit the up arrow, notice how it changes. All of a sudden now we're only preferring 33, and if I do a show IP route, we only install the E1 route to 33. Now the question is the E2 route from 34 still there? The answer to your question is yes, it is. It is show IP OSPF database external. Well, let's do this. Go to the bottom. They're both still there. It just happens to be 33 from a OSPF metric type has been changed to an E1 route. In the OSPF finite state machine, OSPF will always prefer a metric type over a metric cost. So it'll always prefer E1 over E2. I don't care if the E1 cost is 100 and the E2 cost is 10. It's always going to prefer E1 over E2. So in that particular case, I can sit there and polarize my traffic to 33. Now what happens if for some reason I lose my default route? Let's say my default route goes away. So let's actually test that out. Let's fail over. On 33, I am going to go to 26, and I'm going to do a show IP BGP, and I am getting a default route from 27. So what I'm going to do is show run section BGP. I'm going to go to my peering down to 33. This guy right here. I'm going to come in here and I'm going to type in shutdown. I'm going to pretend like we have an outage. Okay, now 33, we got a BGP notification, the peering is down now. Okay, now if I hit the up arrow a couple times and I look at the database, now you'll notice that 34 is my only advertising type 5 LSA. If I go to 13, hit the up arrow, I only have 34 advertising a default route. And if I look at my Ceph internal, I'm pointing to 34 now. So this is the forwarding table. If I do a show IP route, I'm pointing to 34 now. Type 2. Right? I get down to switch 7, I hit the up arrow. Same thing here. I've only got one external default route, which is going to point to 34. Advertising route is 34. I have a default route pointing to 34. I do a show IP route. I'm pointing to only, well in this case here it's pointing to 41, but you get the point. So that is why I do what I do. I will polarize using metric type to a particular egress point in the network. I've done this a bunch of times for a bunch of different customers, for especially we're talking about data center failover and we're talking about OSPF. Well, I can do the same thing with BGP with local preference. EIGRP you can do if you mess around with the delay. We really didn't play around too much with that here, but the concept is the same. So I can do this all day long with OSPF. Now the problem with that is I'm stuck on 34 until BGP comes back online, or I configure a default route, and the reason why. So there's a question of why did the default route go away? Simple. If we go back to 33. One of the commands that I typed in here, do show run pipe section OSPF, is I have the default information originate metric type 1. That command, when typed in, will only advertise the default route if the router itself is advertising the default route. Meaning either I have a static route that is deterministic, so you've got it tied to an IPSLA, where it's pinging a particular next hop IP address that's reachable. And if that static route, if that IPSLA fails to work and the tracking fails, the static route fails. We haven't really, if you go back to the protocol independent routing, I talked about that there. So in situations like that, you have these use cases. But because my BGP default route went away, I'm forcing myself to use R34. Now if I go back to 26 and I hit the up arrow, go and get out of the way, and type in no neighbor, pull that out. I'm going to let that neighbor come back up. 33 comes back online, and if I look at my database, 33 comes back to life. Switch 13 now is using 33. 33 is now my new default route. Switch 7 now sees it as my external type 1 route is being used, and everybody's happy again. So in the event that you have a upstream network failure, then that problem would be mitigated by using the metric type capability. And that's how external routing works with OSPF. That's one of the key things that I wanted you guys to see, is making sure you understand how that correlation comes into play. There's another question, would static routing do the same thing? We haven't demoed it yet, but I'm going to go ahead and show you what that looks like. So let's go on to 34. And on R34, I'm going to, there is no, what do you call it? I don't have a Google IP address here, so I'll have to use the directly attached peering. So I'm going to go to global config. And so what I'm going to be demonstrating here is how you do reliable static routing. Reliable static routing relies on an IPSLA instance, enhanced object tracking, or EOT. And so you create the SLA instance, you tie that to the tracking object, and then you associate the track to the static route. If the IPSLA instance is responding good, so in other words the IP address is reachable, then the SLA instance will be good, the track will be good, the static route will be good. If the SLA instance fails, goes down, then the track will go down, therefore your static route will go down. If your static route goes down, you're up the creek without a paddle. So the way that this would work is this. You type in IPSLA, and you will put in here the entry number, and underneath here you would specify you're going to do an ICMP echo to, in this case here, it's going to be 1.34.42.42, and that's as far as I'm going to take it. There, you can put in here threshold, timeout, frequency, all that type of stuff. So I should be able to say frequency of 5 and a timeout of 15,000. Timeout is greater than the frequency of, yeah, so I'm gonna go ahead and that's okay. IPSLA, let's say schedule, entry number 1, start time is now, and lifetime is forever. And what I'm going to do now is I'm going to type in track track object 1 is going to be an IP SLA entry number 1. And we're going to say reachability. Meaning, can I reach? So state would be, state is the interface up or down? Or I want reachability. Can can it respond? So I'm going to go ahead and do a show IP SLA statistics. And I'm getting an OK response. Number of successes is 7. So if I do a show track, I'm getting it up. So reachability. So we're tracking SLA 1. So now if I do show run pipe and include IP route, I'm going to go over here, and at the end of this, I'm going to say track 1 and hit the enter key. So now I'm tracking my static route. So if I do a show run, the track is attached. Actually, I gotta go to global config and pull this one out. Okay. There's another question. How common is this? Very common. Plenty of customers I've implemented this for. So the next thing I'm going to do is I'm going to go over here to XR42. I'm going to log in, go to global config, and interface gig 000003. I'm just going to shut down the interface. That's going to take down the interface. If I go back to 34 and I ping 1.34.42.42, my ping is no longer responding. If I do a show IP SLA, right there it says reachability is up. So show IP SLA statistics. I'm getting a number of failures as 2. Show track. I'm getting timeout. And if I do a show IP route, I'm getting a default route. I'm getting a default route through OSPF. My static route is no longer there because the SLA instance failed. So if any traffic from 34, if any traffic gets to 34, it'll automatically be redirected. So the traffic flow would look something like this. It's going to go, let's say from 7, it would go here to this guy. Let's say it hit 34, it would get actually hairpinned back out, and then this way is the traffic direction it would go. But it's never going to get that way because the routing is set up correctly. It's going to go directly to 33 and go out to the internet from there. That's going to be the path that it's going to take. So that's essentially what I wanted you guys to see, is how that comes into play. Fairly straightforward configuration, but if you've never seen that before, so I'm going to go back to 42 and I'm going to say no shut. I'm going to commit that. That's going to bring that back online. I'll go back to R34, and then momentarily we should start to see the SLA response come back in. Once there it goes from down to up. So the track is good. Success is 24. The track is up, and my static route is back. Perfect. All right, so that's essentially how you would do both ways. What is the likelihood of seeing both? You could totally put tracking on both routers if you have static default routes pointing to the internet. Totally doable. And then just pick one router that is going to be your preferred egress point if you want to do an active failover or an active standby design. Most customers are not going to do active-active. You could, but in most cases you're not going to do that. So with that being said, that's pretty much what I wanted you guys to see in this particular video and how that comes into play. Because as we get further into areas, now that we're on a multi-area design, it'll get more interesting to see exactly how that comes into play. So if you guys have any questions, comments, concerns, feedback, please drop a comment in the comment section below. If you haven't already done so, please like, share, and subscribe. And I'll catch all of you guys in the next video.